Hi, this is Math Kimchi, and today I will be continuing on the matrix program, and in this video I will be working specifically on matrix multiplication. To first understand matrix multiplication, I found this chart or diagram, and so let's label this matrix. Let's label it A, and the second matrix will be B, and A times B will be equal to the matrix C. So to find the first row, first column, so first row, first column, and that's the highlighted element. To find this, we multiply the first row of A by the first column of B. So the first row, first column is the first row of A times the first column of B. And to find the first row, second column, so that's this element, we do the first row times the second column. And for this, it's a second row times the first column. So second row times the first column, and then we do the second row times the second column, and that's this. So this is equal to this times this. And when I multiply a row by a column, what we really are doing is multiplying the, so for example, the highlighted rows and the highlighted column, we're just multiplying the first element of the row times the first element of the column, the second element of the row times the second element of the column, and the third element of the row and the third element of the column. And after we find all those, we add them all up, and that's what's happening in the highlighted ones, and it's also the same for all of the four other elements. So now let's get to the actual programming. First, let's create a function that multiplies a row by a column, and this takes in the row and the column. So what we have to do is go over each element of the row and the corresponding element of the column and multiply those two, and we add all of the multiples. The final product is going to be 0 for now, and we go over each row or each element in the row and the columns. So for every element number in the range of 0 to however many elements there are in row, we add final product by the element in the row times the element in the column. So we just do row times element number times element number. Alright, and this should be it. So let's see. Let's say that R1 is equal to something simple like 1, 0, 2. And we have to make sure that the row and the column have the same length. And I'm not going to be checking if they're the same length in here, because I'm going to do that in the function that actually multiplies the two matrices. And let's say this is 4, 5, 6. And so what we get when we multiply row 1 by column 1 should be 0 times 4. So the first element of the row times the first element in the column plus the second element of both, and that's added by the product of the third elements both. So that's 0 times 4 plus 1 times 5 plus 2 times 6. And so that should be equal to 0 plus 5 plus 12. And that's just equal to 17. So what we should get is 17. And let's see if that is what we actually get by printing what we get when, before we do anything, let's actually make the function return the final product so we can know what it is. And we have to print row times column and give it row 1 and column 1. Alright, so, and we were getting the correct answer, which is 17. So now that that's working, I'm going to be working on the actual matrix multiplication. And so this takes in M1 and M2. And before we do anything, let's just make sure that the dimensions are correct. And when we are doing matrix multiplication, we want so we're multiplying a row by a column, and we want the number of elements in any given row of the first matrix to be equal to how many things there are in the column of the second matrix. And the amount of elements in each row is just the amount of columns, and the amount of elements in each column is equal to the amount of rows. So we just want the amount of columns of the first matrix to be equal to the amount of rows in the second matrix. If the M1 dimension of M1, we want the amount of columns of the first matrix, so that's going to be the second thing that this returns. We see if that is equal to the amount of rows in the second matrix, and I'm not sure if this syntax works actually, so I'm just gonna try it out. Actually, for that we should check if it's not true, and let's return an error message. And for now, I'm going to be printing dimension match, just so I can see if this works, and hopefully it does. Anyways, let's try to run, or we don't have to print anything. So if we run matrix multiply, and this is a 2 by 2, this is a 2 by 2, this is a 3 by 2. Okay, so M1 times M2 should work because this has 2 columns and this has 2 rows. So let's see if it says, so it says that the dimensions match. And let's see, if we do M1 times M3, this has 2 columns and this has 3 rows, so we should get a dimension mismatch. Alright, so we are getting an error, but the interesting thing about matrix multiplication is that order actually matters. So if we do 3 by 2 matrix times 2 by 2 matrix, it actually should work. And let's see if that happens. So yeah, a 3 by 2 matrix times a 2 by 2 does match. And changing this to another 2 by 2 shouldn't actually change anything. So yeah. And now that we know that this works, let's think. We have a function to multiply these two. I'm going to have a list called product matrix, and for row in range, this number is going to be how many rows there are in product matrix, and the amount of rows in the product is equal to the amount of rows in the first matrix. So because if you had something here, then it would be third row, first column, and that wouldn't work because it doesn't have a third row. This has to be how many rows there are in the first matrix. So that's just the length of the first matrix. And let's create something called a product row. And this is also going to be a blank. So for column in range of 0 to... So this is how long a row is going to be in the product. And that's just how many columns there are. And the number of columns in the product is equal to the number of columns in the second matrix. So to find that, we just do the length of matrix 2, and we have to find a length of a random row in matrix 2. So let's just use the 0. And alright, so this should go over every single element in the product row. So let's see. What we can do is, let's say the row was 1 and column was 1. Then it would be the first row times first column, or the 0 times the 0th column. So we do the 0th row of A, or actually I'm gonna do the 0th row times the first column. Yeah, and that's this 0 and 1. To do that, we have the 0th row times the first column. So product element is going to be equal to the row times column, and the row is going to be the rowth row of the first matrix. All right. So that is, actually, this is the rowth row of M1, and that should be it. And for the column, it's going to be the column of M2. So that's column of M2. It's the row of M1. I don't think there is an easy way to find the column, so I guess we can create a new function called column finder, and it takes in the matrix and the column number. So column is going to be equal to an empty list for now, and we can go through everything. So for column in range, I think this has to be, let's see, so the length of column is going to be how many rows there are. So this has to be how many rows there are, and for every column you just add, actually this has to be column number. So element is going to be I'm just gonna call this row. An element is going to be equal to row and column. So it's going to be the columnth element of the rowth row of the matrix. No, this has to be column number, and we add element to column. At the end, we return column. And I'm gonna see if this works. Print column finder, and the matrix, let's give it M3, and the row, let's try 0. So 135, 135. All right, and if we give it the first row, then it would be 2, 4, 6. So let's see. All right, so column finder is all working. So the multiplied column has to be equal to M2. The column number is column. All right, and product element equals row times column, and the row is multiplied row, and the column is multiplied column. And I think we just have to add product element to product row, and not append, and we give it product element. And once we go through every column, we add product row to product matrix. All right, and now we just have to return product matrix. So let's see if this works. I'll actually create 2 new matrices and 4, and this is actually just gonna be equal to A and B. And actually I'm gonna do this to make it easier to see. Actually, I'm gonna do that to all of the other matrices. For M5 is going to be equal to 10, 11, 20, 21, 30, 31. 10, 11, 20, 21, and 30, 31. And so if we do M4 times M5, then we should get 140, 146, 230, 235. Let's see if that's what happens. Oh, and we have to print what we get. All right, 140, 146, 230, 335. Wait, 320. Oh yeah, 320, 335. 335. All right, so matrix multiplication is now working, and that's it for this video. Thanks for watching.